So chain rule, next thing that we're going to learn. And it's what you do when you have exponents involved and you have to find the derivative of something and you have parentheses to contend with. So a problem like that. Now you can use product rule with this, but we're going to learn how to do chain rule. It's a little bit faster. So chain rule is when you have parentheses involved, when you have something in parentheses taken to an exponent. And it changes a little bit about how you do the derivative. So here's what happens. So you're going to use your derivative rules like normal. And the derivative rules were take your exponent, bring it forward, and then subtract 1 from your exponent. You're still going to do that here. So I'm taking the derivative of y. The exponent comes forward. I put a 2 in front. Don't change anything in the parentheses. 2 minus 1 leaves me with an exponent of 1, which I and you have this added step now, okay? So this thing in parentheses has to be dealt with. And so now this is where the chain rule comes in. You multiply that, so you're tacking on to that, multiplying by the derivative of what was inside the parentheses. That's the chain rule. You're creating a chain effect. So the derivative of 2x plus 3 would just be 2, okay? Because this is really x to the first. And you bring the 1 forward and you get 2 times x when you subtract 2 in front. When you subtract 1 from your exponent, you get x to the 0 or no more x's. So that's why we just have 2 right there, and then we know the derivative of 3, which is a constant, is 0. Okay, so the last step would just be cleanup. We don't want a number here in the front and a number there in the back behind the parentheses, so combine those two things. 2 times 2 would be 4. So our derivative would be a 4 in front, 2x plus 3. Now on this one, there is no exponent out there because really it's to the first power. And so you would want to go ahead and distribute the 4. You cannot distribute. We couldn't distribute inside if you had another exponent. Like if you had squared right here, you can never distribute into something that's being squared or cubed or something like that. Okay, so that one we would not be able to do, but this one we have to the first, so we are allowed to do that. And that gives us our final answer of 8x plus 12, and that's our derivative. Now remember, you can do y prime to indicate that you've done the derivative, or you can say the derivative of y in terms of x, so we call that dy dx, equals 8x plus 12, or sometimes you'll see it as just dy equals, and you'll see the dx on the other side out here. All of those are fine. It's just a different way to write what we have.